Today's webinar is on maths, measures, shape and space, although I'm going to change that a little bit because I'm going to do shape and space first and then go on to measures. One thing I'm aware as I've been looking at this and setting it up, shape and space is quite a relatively big topic. There's some, I was going to say complicated, that's probably too strong a word. There's some detailed maths in there, so I'm going to take some time to go through it. I am aware that we say these webinars take about half an hour, and it may take me that long to go through the shape and space section. So what I'll do once I've done shape and space is I'll take any questions. Then if anybody has to disappear because we've run over time, you're welcome to disappear, and I will carry on doing the measure section. If you haven't got anywhere to go and you want to stay with me, then that'd be very nice. We'll go through measures, and if not, we will be recording that section as well. So if you do need to disappear at any point, please do just log off, and I'll send you the recording afterwards. But I'm not saying it's going to last 2 hours or anything like that, but we may just go a little bit longer than sometimes. So I wanted to warn you at the start. So looking today then at measures, shape and space, and say starting with shape and space. By the end of the workshop, what we're going to do is talk about some key measurements of weight, length, volume, there's various other words you can use in there, but some of the key measurements you need to know. And we're going to look at the three main things that you're working out for three different shapes: the perimeter, area and volume, of three key shapes that could come up in the functional skills test. And then, as I say, separately looking at the measure section, we'll look at converting currency and converting distance and looking at map scales particularly. So those sort of follow on a little bit from the last webinar where we talked about ratio. If anybody was at that or was in the recording, they follow on quite nicely from that, but they are specific to measures, if you like. That's why I put them in here. So some of the key measurements you need to know. People often ask me with shapes and spatial measurements whether I've got to remember all different conversion rates and things like that. You're not expected to. You're certainly not expected to remember conversion rates for imperial to metric. So you're not meant to know how many feet are in a meter or how many inches go into a centimetre or the other way around, what it might be. There are some key measurements that you're sort of expected to know. And hopefully you may know these, and if not, they're on the screen. You can make a note or we'll have them afterwards. So in terms of weight, the main one to know is that 1,000 grams, if we weigh things in grams, 1,000 grams equals a kilogram. Is something to key. Kilo means 1,000, so the way to remember it, but 1,000 grams when you're measuring something can equal a kilogram. In terms of volume, usually to do with liquids, 1,000 millilitres equals a litre, and similarly 100 centilitres also equals a litre. So as you can tell there, 10 millilitres actually equals a centilitre. You don't usually do that conversion. It's usually millilitres to litres or centilitres to litres, and they are 1,000 or 100. The one that's probably more common, well, in fact, I can pretty much guarantee that almost every one of you will have something to do with centimetres, metres, kilometres in your test. And that is exactly what you see there. So if you think of a ruler, the very small lines on a ruler are millimetres, and there are 10 of those that go into a centimetre. If you think of then a metre rule, 100 of those centimetres go into 1 metre, size of width of like a table or something, if you imagine it. And then if you're thinking of a larger distance, 1,000 metres go into a kilometre. So I was going to say if you're doing a run, well, it's not me. If you're doing a very slow walk, you may do 1,000 metres to be a kilometre. So quite often you might have a need in the test to go from millimetres or centimetres up to kilometres. So there's a couple of steps there. I will give you an example when we talk about measures a bit later. But that's something to be aware of. Those aren't usually given to you in a test, the things that are on the screen, but you are expected to know those. So they might be a little bit of revision for you. So I've mentioned we're going to look at perimeter, area and volume of three different shapes. So for the first one, I'm going to go off that and go to my whiteboard, which if you've been on these webinars before, you'll know you use quite regularly. So what I'm going to do is I'm going to talk through examples. I have got a presentation that sort of got the key words on it afterwards, but the main thing to look through is the presentation here. So I want to think about a four-sided shape, rectangle, square. That's as straight a line as I'm going to get on here, I think. It's probably better than I thought it would be. So, and we're going to use this example. Let's say this is somebody's back garden. We're looking down on a back garden, and the back garden is 4 metres that way and 3 metres that way. I purposely use the words that way and that way rather than length, width, depth, and those kind of things, because it depends on how you look at something, whether it's a length or a width. And actually, it doesn't really matter which one is which. What matters is you've got one side that's 4 metres and one side that's 3 metres, and it makes it into a square or rectangle shape in this case. So the first thing we may need to work out is what's called the perimeter. On the chat function, can anybody tell me where the perimeter of a shape like that is, or what the perimeter is? And I'll over to you, Eamon, to let me know if anybody's responding.
Okay. 14?
Not necessarily the number, although that is correct. Where is the perimeter? What are we measuring if we're looking at the perimeter?
Joe said, is that the outside?
Spot on. So the perimeter is simply the outside of this shape. So if it was a garden and we wanted to put gates all the way around, which would be a bit strange because you wouldn't get in, fences all the way around with a gate somewhere, we'd need to know the perimeter. And as somebody else said there, it is simply the measurements of all the outside. So we can see the left-hand side here is 4 meters, and we can see the top is 3 meters, so it's 4 add 3. And we've got another side on the right here, and that's obviously going to be 4 because it's a rectangle, and the bottom's obviously going to be 3 again. So we add all those together, and you're right, whoever said it, it is 14 meters. Our symbol is meters because our measurements were in meters. We haven't changed that at all. So basically, I've walked 4 meters one way, 3 meters across, back down 4 meters, and back 3. So that gives us a total of 14 meters. So perimeter is simply add up all the sides, and a nice square or rectangle shape like that, you can see that the sides match. So perimeter is simply adding them all up. Rub that out and write it, it's 40 meters. Area, so if perimeter is outside, anybody want to tell me in the chat where the area is or what we're working out with the area?
Nothing's come through just yet.
That's good. Slightly more difficult, the area.
So Joe said the inside, Hafiza said multiply the side.
Brilliant. Both of those are spot on. So if we're working out the area, we're working out the space in between this. So in this case, if it's a garden, we might be working out the amount of grass that's in the space. And for the area, all we want to do is multiply one side by the other. We know one side is 4 meters, and we know the other side's 3 meters. So if we multiply those together, we get 12 meters. And we should use this little 2 symbol to symbolize meters squared for the area. And I'll explain why in a moment. One thing to mention at this point in the test, you can't do a little 2. So you could just put M2, or you could write meter squared, or sometimes it might even give you that symbol there for you, and you've just got to put in the 12. So if we go back to our little grass area, if we can rub all that out. Okay, if we think about it, this is a nice, I've used relatively easy numbers, 4 meters by 3 meters. So if we were to draw 1 meter squares within this garden, we'd have 3 going across, not quite to size, but that's okay. And we'd have 4 going down. And obviously that would give us these filled in as well. And if we counted those, 3 across and 4 down, gives us a total of 12 squares. So that's what we get our answer of 12 meters. And if you think of them as squares, that might remind you to do that little 2 with meter squared. Only a very small point having that meter squared, but it's important to get that right as well. So whenever you're doing perimeter, you add up the outside, or the 4 sides. And if you're doing area, you just do one side multiplied by another. The other thing you may need to do is what's called volume. And this is where my example of a garden falls down. So volume is the amount of something that can stay within an object. So let's say instead of this a garden, we're looking down on a swimming pool. I'm not sure, but we're looking down on a swimming pool again with the same dimensions. And one thing we know, the height, and actually, let's be correct, shall we? We know the depth of this swimming pool is, let's say it's 2 meters. Yeah, well, big or small or not. So to work out the volume, the easiest way to do it is to work out the area first, which we did as 12 meters squared. And we just want to multiply that by the other dimension. In this case, I'll call it depth, or it could be the height of it, with the other dimension that you haven't used. And 12 times 2 is 24 meters. And this time we use a little 3, which shows, it's meant to be a 3 anyway, which shows that we're doing meters cubed. So if you think about it, it's a cube, so a 3D shape rather than a flat shape. So we're doing 24 meters cubed, and that's the difference between meters squared area and meters cubed in volume. So if I delete all of that, and let's just do a smaller version just to emphasize my point for volume. Again, no awards for the graphics, I'm afraid. But let's say this is a box that is, or a small box anyway, 3 centimeters by 3 centimeters, and it goes back by 6 centimeters. And again, I've specifically said goes back because you could call it the depth, you stood it up, it'd been its height, or you could call it length or width, depending on how you were looking at it. So the calculation is you want to multiply all the sides together, but one way to try and hopefully remember it might be easier is to think about, I'm going to work out the area of this flat shape at the end, which we've said area is just one side times the other, which equals 9. And once I've worked out the flat shape at the end, I'm going to multiply it by how far this item goes back. And we know that that's 6 centimeters, so we times it by 6, which gives us 54 centimeters cubed. So relatively straightforward, and I know these are nice straight shapes, but they're very common things that you'll get. One thing you may have noticed is that all the measurements have been the same. So in the last example with the garden or the pool, everything was in meters. On this page, everything's in centimeters. The difficulty comes if you haven't got the same measurements. So if this said it was 3 centimeters by 3 centimeters by 12 millimeters, then we can't do this same great calculation. We would need to convert from millimeters into centimeters, which is what I mentioned at the start, and I will mention when we come on to maps a bit later. So before you start, you need to be sure. It doesn't matter if this was, let's change that a bit, 3 centimeters by 3 centimeters by 22 millimeters. You can either change these two into millimeters, so everything's in millimeters, or you could change this one into centimeters, so everything's in centimeters. It doesn't matter which one you use, but you need to make sure they're all the same. If you multiply centimeters by millimeters, you'll get an incorrect result. So hopefully that's useful. Then we're all nice straight shapes. This one won't be. And again, no prizes for my drawing, and it's certainly not to scale, I should say. So let's say this is a living room in somebody's house, and we know some measurements. We know that this side is 7 meters, this side is 5 meters, this side is 9 meters, and this side is 2 meters. And we're going to work out the perimeter. And we said before that to work out the perimeter, you add up all the sides. And we have a bit of a problem here because we don't know at the moment how long that side is or how long that side is there. So we need to do something about that. So let's have a look at the shape as it is. Well, let's take this side here. We're going to try and work out. So if I think about all the way along there is 9 meters, as you can see at the bottom. And we know that that bit there is 5 meters because we can see at the top. 9 take away 5 is 4. So this leaves us 4 meters in this little gap here. Pick those and I can write in 4 meters. And if we do the same this way, all the way down is 7 meters. We know that this gap here is 2 meters because it says so at the end. And so this must leave us with 5 meters left here. So we can write that in. Just delete some of those lines first. And this leaves us 5 meters as well. So the first thing we had to do was work out the missing sides. We could now add up all those sides together. And I can tell you, because I cheated and did it in advance, that would equal 32 meters. If I was just 7, add 5, add 5, add 4, add 2, add 9. Problem now a little bit is when we come to area and working out the area of this shape, because it's not a nice square or rectangular shape, as we said before. There are 2 possible ways of working out the area, and I'm going to actually show you both of them, and I'll mention why I've shown both of them in a little while. I'm usually quite a fan of just choosing one way, finding a way that works and sticking with it. But in this case, I'm going to tell you 2 options, and so you can see why. So, first thing I'm going to do is to work out, let's get color coded again. I want to work out this full shape. And so what I'm going to do is I'm going to divide the shape up. We know that squares or rectangles are easy to work out. So I'm actually going to split it into 2 squares or 2 rectangles by that line. I could split it there and be exactly the same, but I've decided I want to split it there just because I want to. So let's take this section first, this orange section. And we can see, we said area before is one side times the other. Well, this orange section is 7 meters that way and 5 meters that way. So 7 times 5 equals 35. And let's do a blue color. And we've got this little section here. And we can see from this blue that we know that this side is 4 meters and it goes down by 2 meters. 4 by 2 equals 8. And to get our final answer, we need this side and this side. So we simply add them together, which gives us a total of 43 meters squared.
Elena give us that answer as well.
Say again.
Elena's just commented and give.
Fantastic, that's good. Beat me to it, so that's good. So we worked out the orange side and the purple side, add them together and give us 43 meters squared. So if this was a living room and we wanted to put carpet down, we need 43 meters squared of carpet. I said I'm going to give you another method to do this as well. So I'm going to have to undo all of that to make it not quite so colourful. So I'm just going to note in the top corner here, the top left corner, the number that we got there, which was 43 meters squared is what we said. And I'm going to use another method, but prove that it comes out to the same answer. So let's go for a green. And what I'm going to do this time, instead of taking them as 2 sections, I'm actually going to extend this. I'm going to make a full square, or full rectangle in this case, for the whole shape. To work out the area of the whole thing, including that green section, we know one side is 7 and one side is 9. So 7 times 9 equals 63. But we don't actually want, let's go to orange again. We don't actually want this section here. And we can see that this section is 5 by 4. So in orange, if we do 5 by 4 equals 20. And if we take those two away, because we don't want this section anymore, 63, take away the 20 is 43, which is the same answer we had before. So either method is absolutely fine. It's completely personal preference, whether you do the method where you split it and think of it as two small squares and put them together, or whether you think of the overall shape as a bigger one and then cut out that square there. Sometimes it's easier to imagine something that's there rather than not there. I personally prefer the first method. Some people prefer the second. So two reasons for telling you. One is because it is personal preference, and as you saw there, we get the same answer. So it doesn't really matter which one you do. As anybody who's done any practice tests or practice questions know, occasionally you are asked to check your answer in functional skills. You sometimes work out an answer and it will say check that your answer is correct. If you got that in this kind of question, this would be perfect because you've got two different methods there. So if you do the method normally, you get the answer of 43, and then the question, and then the question says check your answer. And then you can use the alternative method, get 43 again, and then you know that your first answer must have been correct because you've checked it and you've got the same number. So that's one of the reasons why I gave you two methods here, is because you may get to use both of those in your maths test.
We just have one question.
Yeah, go for it.
A lady just asked, will we be able to use scrap paper in the test to work out in rough?
Yes, as much scrap paper as you want. Obviously, unfortunately, you can't take any notes into the test. But you can't, as much scrap paper as you want. As most people probably know, there's for the older version of functional skills, if you're doing that, you get marks for your working out pretty much in every question. For the newer version, there are 15 questions without a calculator where you don't need to show any working out. 15 questions or 15 marks. And then the second lot of questions, 15 questions, are a bit more, you can use a calculator, a bit more working out, and you can get some points for that, some marks for your working out. So if this question comes up in that latter half, or for anybody in the older version of functional skills, if you want to show you working out, so I've actually got rid of my grid now, unfortunately, but let's run this. So if you wanted to say you were working out the perimeter and you wanted to show 7 add 4, my example was, my perimeter was 4 add 3 add 4 add 3 equals 14, and you've shown you working out. So actually, if you've made a mistake and you've typed in 2 rather than 3, you might get some marks for your working out as well. So in a nice square or rectangular shape, 4-sided shape, you can add all the sides together for the perimeter. For the area, you multiply the 2 sides together. And for volume, you're multiplying all 3 dimensions. The way I would recommend think about it is work out the area of the flat side first and then multiply it by how far it goes back or up or down or left or right or whatever the third dimension is. But that's nice if you've got a nice straight shape. You may have to do some extra work in the shape as well. The other thing I'll say is, you may get questions saying, what is the area of this shape? A bit like that garden we did. What is the shape of, what is the area of this garden? You're more likely to get some follow-up questions. So you need to order grass seed for the garden, and grass seed, you need to have, grass seed costs, I don't know, £7 for 1 metre squared of grass seed. So you need to work out how much grass seed you need. Well, you work out that you've got 35 metres squared area. You times that by the price of the grass seed and you've got the total cost. So usually area particularly may be part of another thing. I gave the example when I said a perimeter around a garden might be working out how much fencing you need, but the actual question is to work out what would the cost of the fence be, but you need to know the perimeter before you know how much fence you can buy, so how much it will cost. So you may find when you're working out any of these, there's actually like a follow-up question. You do these first, and you have to put them into some sort of context afterwards. Okay, so that's our lovely 4-sided shapes. And as you can see quickly on the screen there, we're now going to look at 3-sided shapes known as triangles. And triangles can take a number of different forms. There are different names for them. There's isosceles triangle, and there's right-angled triangles, and equilateral triangles, and various other things as well. It really doesn't matter what the shape of your triangle is. There are some common elements to all of them. The first thing to know, and again, they're not very straight shapes, I'm afraid, but they're close. The first things to know is every triangle, because it's got 3 sides, it has 3 points, also known as 3 angles. And those 3 angles will always add up to 180 degrees. So no matter what shape of the triangle is, your internal angles will always add up to 180 degrees. So if I give an example of this triangle, it's actually a right angle triangle because we've got a right angle there, which is 90 degrees. And if I tell you that this angle here is 60 degrees, you may have to work out what is this angle here. And I've said the internal angles always add up to 180. So if we do 180, take away 90 and take away 60, because we know those, That leaves us with 30 degrees. So this angle here must be 30 degrees. So that's something you may get, certainly on the newer functional skills. They may ask you for the missing angle. You may remember at school some very complicated things around angles. The easiest thing to remember here, though, is the 3 internal angles will always equal 180 degrees. They should give you 2 of them, so it's a matter of just taking a to work. You shouldn't get a question about the perimeter of a triangle. Those who are doing the older functional skills, I've been 15 years, and I think about 10 years functional skills been going, I've never seen a question asking you to work out the perimeter of a triangle, so you should be okay with that. Have seen one in the newer version of functional skills, but it does what's called an equilateral triangle. And again, while you don't need to know the name, equilateral probably makes you understand that it's equal. And that basically means that all 3 sides are equal. So if I told you this was a triangle and this was 8 centimeters across, well, all 3 sides are exactly the same. So they're 8, 8, and 8. Similarly, all 3 of the angles are exactly the same, and we said they all must add up to 880. If we do 180 divided by 3, we get 60. So each angle of an equilateral triangle is 60 degrees. Again, I'm not worried about you remembering the name. What you need to bear in mind is if it looks like a triangle that looks exactly the same, that's what it is. So the internal angles are all 60, and that adds up to 180, and the outside measurements are all exactly the same. So if they give you one measurement, you've got to know what the other 2 are straight away. And you shouldn't be asked to do any more perimeters than that. If that starts coming into the syllabus, I'll backtrack on that and I'll be supporting people how to do it. But I don't want you to have to know something that you don't need to know in this case, because it can get a little bit complicated. So that's perimeter. If you need to do it, it's very unlikely. Let's look at another triangle. I mean, I'm not worried about how straight it is or the type of triangle. And I'm going to give the measurements for this triangle. And I'm going to say it's 6 centimeters. And the height of the triangle, let's say, is 4 centimeters. Again, not to scale. To work out the area, there is a formula which might look complicated, hopefully it doesn't, but actually I want to break down into much easier than the formula. So the formula is half BH, where B stands for base, or the width of it, the line going across, and H, you've probably guessed already, stands for height. So that's the formula. You may remember if you've done formula webinar with us or seen formula before, when you've got 2 numbers, 2 letters next to each other, or a number next to the letter, you always multiply them. So BH there simply means B times H, or base times height. And the numbers for here, our base is 6 centimeters, our height is 4 centimeters, which gives us 24. And you'll notice here that I've conveniently forgotten about the half bit. So to half something, we just divide it by 2, which gives us a 12, and we're in centimeters, so that's centimeters. And if you remember when I said about area, it's squared, so it's 12 centimeters squared. So seeing that formula of the half BH can be a little bit confusing, but actually we're talking about half of the base times the height, or one measurement times the other, and then split them in half. If you want me to prove why that works, if we think of this as a full square, to do the area of the square, we would do 6 by 4, one side by the other. And as you can see, you're taking away half of the square there and only leaving half of it. So that's why once you got the answer, you divide it by 2. And again, that's nice straight shape in that triangle, but it doesn't matter which triangle you're going for. To work out the area of the triangle, you do the measurement is the base times the height, and you half it, or you may say half BH. The reason I mentioned that you'll see that is sometimes in the test, it will ask you to work out the area and not give you that formula. And sometimes it may give you that formula, and you may look at it and think that's a bit confusing. As you can probably appreciate, about this at the bottom. Another way to write that would be BH over 2, means the same thing. Base times height halved. So I'm not too worried. If you see the formula, I don't want you to think, well, hang on, what's that formula mean? I want you to remember that to work at the area of a triangle, you do half, you do base times height, and then you halve it. So triangles aren't as much to remember, fortunately, as squares. So the 2 sort of key things for triangles is it doesn't matter what the shape of the triangle is. If it's a 3-sided shape, 3 dots and 3 corners, such as that, it's a triangle, and all of those internal angles will always add up to 180 degrees. You shouldn't have to work out the perimeter, but if you do, it should be relatively straightforward because you'll be given an equal size triangle. But you may have to work out the area of a triangle, and to do that, the formula is half BH. What that actually means is you do the base, which is across the bottom, multiplied by the height, how high it goes, and then you split that answer in half. Triangles, I think, are a little bit easier, hopefully. Any questions so far?
No, nothing just yet. I was talking to myself.
That's quite right. If you have got any questions, then, as you know, just ask at any time. So we're now going to move on to the joyous world of circles. I'm going to try to draw a circle here. I'm never very good at. Oh, that's better than I usually do. So that's meant to be a nice round circle, but it's as close as I can get on this screen. So the first thing to look at is if you like, the anatomy of a circle. So can anybody tell me in the chat? Well, actually, I'll draw first. So the outside of a circle, when we're doing squares and triangles, we call it perimeter. The outside of a circle is called something that begins with a C. And if I drew a line all the way across the middle of a triangle, of a circle, sorry, it's something beginning with D. And if I drew a line half the way across, it'd be something beginning with R. Can anybody tell me what those three words are, or any of the words? Something beginning with C, D, and R.
We've got circumference.
Is correct.
Right. Circumference, diameter, and radius from Ian.
My handwriting is not the best. Perfect. My handwriting is not the best usually, but writing on here it's even worse. So when we talk about the outside of a circle, instead of saying perimeter, we say the word circumference. Don't quite know why, we just do. A line going all the way across the middle of a circle is called the diameter, and a line going halfway across is called the radius. Obviously, again, this isn't a very straight circle, but as long as I go through the middle, it shouldn't matter where I draw my diameter. Oops, not like that. As long as I go through the middle, I said. Wherever I draw my diameter will always be the same measurement if it's a true circle. And therefore, wherever I drew the half a line, again, shouldn't matter. The radius will always be the same. And as hopefully you can appreciate there, if my diameter was 6 centimeters, well, the radius is simply half of that. So the radius would be 3 centimeters. So what you might find, we're going to do some calculations in a moment where we use the radius. You may find quite common, the question will give you the diameter. One of the first things to do is work out and use the radius. So I'm just going to rub some of these out. I'll leave the letter C, D, and R, and hopefully you can remember what those terms mean. So to work out the circumference, the outside, or the area, the inside of a circle, there are two different formulas we're using. And again, I'll do a plug. If you haven't done our formula webinar, it may be useful to go back and watch that one, because that will help you a little bit. I used to be able to say to people, and the good news is you don't need to remember these formulas because they'll give them you in the test. As time has gone on, both the old functional skills and the new functional skills, I have seen a number of tests where they haven't given you the formula. So to be sure, I would recommend trying to remember these formulas. There's only two, and you may have seen them before. They are very similar, unfortunately, but to try and remember them would be very useful. So if you were working out the circumference of a circle, the formula used is this, and it's 2, as in the number 2, pi r. So the first alarming thing to note is we've got this weird symbol called pi, looks a bit like a double T or whatever it might be. Pi as in pi, as in a Greek symbol, not pi as in something you eat. Pi, the symbol, has been around for thousands of years. I believe it was the Greeks who found it about over 4,000 years ago. And it's to do with the ratio of, say, outside of a circle related to the radius or the diameter, the inside of the circle. Very interesting pi if you want to look it up. Pi is a figure that goes on forever, because if you think about a circle, you could never draw a perfect circle. You could always make it a bit more refined and a bit more refined. So actually, the relationship of the circumference to the line across it, the diameter, can go on forever. So pi is a figure that actually continues with nobody found an end to it yet, which is a strange math concept. I do know that somebody once memorized pi up to 100,000, I think it was, figures, and memorized 100,000 numbers, which is amazing. And I know last year, maybe this year, earlier this year, Google used one of the supercomputer to work out pi up to 31.4 trillion figures. I wouldn't recommend trying to do that for your functional skills test. What is useful to remember is what we normally relate to pi, and you may have seen this before. We often call pi rate as 3.14. As I say, that goes on forever after that, but we're usually round to 3.14 is a good number, good estimate for pi. Once again, sometimes in the test they will tell you that. They will say, here's the calculation using pi as 3.14. Sometimes they don't give you that and you've got to remember it. So if you weren't at that already and you can remember 3.14, it'll certainly do you no harm. And might come up as a quiz question at some point as well.
I think Joe's just commented saying we don't need to know that, do we? But you just answered the question. Yeah,
well, so if you asked me 2 years ago, I'd go, no, don't need to remember that, you'll be fine. I'm now not so sure. If you're doing the old functional skills, I'm pretty confident, 98% confident, that you don't need to remember because they will give it you. If you're doing the new functional skills, because it's new and we haven't done many tests, I'm not sure. I do know there's a practice test where they don't give you. I am also aware, just to throw in something else, is there is one test where they tell you that pi is 22/7, which is correct. If you do 22 divided by 7, it gives you 3.14 something. That is not a term that many maths people would use for pi. I'm not quite sure why they do that, and I'm not sure they'll do that in the real test, but I do know they do say that over a practice test. If you can remember 3.14, it's not a bad thing to remember. And as I say, it's one, sometimes people just know it. I often say to people, do you know what pi is? And they'll say that, and they don't know why or why they've remembered that from school. They just have. So if you can remember that, it's useful, but maybe not essential. So going back to our formula, again, if you haven't done the formula webinar, then I tell you, I mentioned before, whenever you see a symbol or a letter or next to a number, there's no sign, there's no add, take away, times, or divide. You always multiply them. So our formula of 2 pi r simply means 2 times pi times r. We know, because I just told you, that pi is 3.14, so let's get rid of pi and let's put 3.14 in there. And you probably guessed already, when we're talking about circles, we said r, and we know r is in our circle, which is our radius. So in this case, our radius is 3. So we can change the letter r for 3. And you'll get to use a calculator for this bit. And I did it before. And your answer here is 18.84. And we were in centimetres, so it's just centimetres. So the circumference of this circle, using the formula 2 pi r, is 2 times 3.14 times the radius, which is 3, gives us an answer of 18.84. I mentioned before that you may find in the test they give you the diameter, not the radius. So if you were to jump in and you shove 6 in there, you're always going to get a completely different answer, and that would be wrong. So it's very important that you use the radius. In this case was 3, even if they've told you the diameter. To do that, it's not a trick. There's no such thing as a trick question, but it is something they often give. A circle with a diameter of 6. What is the circumference? First thing you have to do is know that the radius is 3. So the formula to hopefully remember, hopefully they will give you in the test, and that will be better for you. But if not, if you can remember that it's 2 pi r, and that simply means 2 times pi, which is 3.14, times the radius. Now, if you were thinking, okay, that's a bit to remember, but I think I can do all right with that, I'm going to throw a bit of a curveball, I'm afraid. And it's not me doing this today, this is maths for you. So the area of a circle uses another formula that unfortunately, well, I don't know, yeah, I think it's unfortunate, is very similar and can cause confusion between them sometimes. And this formula for working out the area is pi r squared. So as you see, we've actually got the same symbols, pi r and a 2, they're just in a different order and a different shape. So we've got pi r squared for the area. Well, pi is still pi, we know, and we said it was 3.14. And we're going to times our radius squared, which in this case was 3 and squared. Whenever you're asked to square any number, well, actually, I'll ask the question on the chat again. Does anybody know how you square any number or what the square of 3 is?
Hafiza said area is in square, so r square.
I'm going to come to that, but that's a very good way to remember it, yeah. Anybody know what 3 squared would be?
That's 9.
I missed that there, but I'll show you. So whenever you square a number, you simply multiply it by itself. So 3 squared is 3 times 3.
Ian just said 9.
Brilliant, thank you, Ian. Just before I wrote it as well, so you still get the bonus point for that. So pi r squared is pi times 3 squared. And we know whenever you square a number, you simply multiply it by itself. So in this case, it's 3.14 times 9. Our answer, therefore, is 28.26. And we were talking about area. So if you remember when we talked about area before, I said your measurement, in this case centimeters, squared is how you write the answer. And somebody just said there, the tip that the way I remember which is circumference and which is area area has this squared, r squared in it. And we know the area answer is always square, centimetre squared, metre squared, inches squared, whatever it might be. So a way to remember the area is pi r squared is think, well, it's squared, and I know that area is squared, so that's good. The way to remember circumference is 2 pi, is the other one basically, so it's 2 pi r. So I realise there are a bit more clear maths in there, pure maths if you like, and a bit more to remember. But hopefully, if you can recall those 2 formulas, that'll be helpful for you. So that's circumference. So we've talked about perimeter in other cases, but in this case we call it circumference, and that's area of a circle. Final shape I'm going to go through involves a circle, but it's a cylinder, 3D shape. This could be a can of beans or Coke or, I don't know, a bucket or anything like that. And once again, it will give you some dimensions. So I'm going to stick with the radius of the top being 3 centimeters. So actually the top circle is exactly the same circle as we saw from above a moment ago. And the tin of beans goes down about 10 centimeters. Like that. So that's what I'm going to put. When we did, so if we want to work out the volume, which is the amount of stuff that's in this can here, When we did squares before, I said the easiest way to work it is work out the area of a flat shape and then multiply it by whichever dimension you've got left, depth, height, width, whatever it might be. So if we did the same again, we know the area of a circle is still pi r squared. And we just worked that out a moment ago to be 28.26. So this flat edge here at the top of our can of beans, or it would be the same at the bottom, 28.26 is the area. And we've got it, the depth of the can is 10 centimeters. So all we do is times that by 10, which would give us 282.6. And we're in centimeters. And remember, for volume, we're talking about centimeters cubed, which we show with a little 3. So working out the dimension of a cylinder like that is probably one of the hardest things you will do on the functional skills test. However, if you think about it, well, you know how to work out the area. So rather than trying to do it all together, I'm going to work out the area at the top of the can, and then we're going to multiply it by how far back the can goes down or up or back or left or right or whatever it might be. And that's how you work out the area of the circle. So if I go back to the presentation, the triangles. So key thing to remember is diameter goes all the way across and radius is the middle. We're usually using radius when it comes to circles. So if they do give you the diameter, look out for that. To work out the circumference, the formula is 2 pi r. To work out the area, which is a bit inside, the formula is very similar, but it's pi r squared. And we know that when we've got formula, all we're doing is multiplying those numbers and hopefully remember that pi is 3.14. If we work out volume, we're going to work out the area of the flat shape, and then we're going to multiply it by the height, the depth, or whichever dimension we've got. And as I said before, the key thing to remember is radius is half the diameter. Two final things I'm going to mention in this section before we look at some of the measures that I said. Two final things to shape and space. First thing is a bit of a tip. Sometimes in the test, they will give you a formula, and it may be slightly different to the formula you've got. So I've mentioned for a triangle, the formula is normally known as half BH, but it could be written as BH over 2. I can tell you that, well, I won't draw it because it will just cause confusion, but there are other formulas for working out or the slight differences of working out the area and circumference of a circle. 2 pi r and pi r squared are the ones that are predominantly used and are the standard, but there can be some slight tweaks to that. And they may even give you a really complicated one because it involves a circle with a cylinder with a sphere on top and those kind of things. If the test has given you a formula, as I say, forget everything you just learned for the last half an hour on here and follow that formula. We know that when you have a formula, if a formula is 2f take away r, we do 2 times f first and then we take away r, whatever those letters might mean. So if you see a formula in the test, if they say work out this calculation using this formula, I would say forget everything you learned and just use that formula, and I'm going to follow that formula because that's what they've told me to do. If they don't give you the formula and say work out the area of a circle, you've got to remember, well, the area of a circle is pi r squared, and then you follow your own formula. So I just want to say, if they give you a formula, I would suggest, rather than thinking, well, that's different to my formula, I'm going to dig in and use what I know. Actually, why do that when they've given you a formula? And actually, if you're getting marks for your working out, they want you to follow that formula. So if there is a formula given in the test, I would strongly recommend following it. The other thing I wanted to mention is I've done some hopefully relatively straightforward and easy to view shapes here, but nothing's very straightforward and easy to view in maths. You could be given a shape like this. Let's say this is a garden again, and they could say that, and the garden, it's not very well drawn garden, but the garden has a pond there, and it might have a little decking area here, and everything else is grass. And the question might be working out what the area of the grassed area is. Looking at that, there's a lot of things here, and where do I go? But let's break it down. And I'm not going to give some figures here. I'm just going to show you how to work it. The first thing I would recommend do is working out the area of the whole shape. So the way we could do that, if we view this in red, might be better. Let's make that bigger as well. So the area of the whole shape, I would work out the area of this square here. We know to work out an area of a square, one side times the other. And then I could work out the area of this triangle. And we know the area of a triangle is half base times height. And I'd add them together, so I'd have my total area. And I'd be happy. I could then work out the area of this pond. And I know how to do that because the area is pi r squared. So then I would take away the area of the pond. And I don't need grass in my decked area. And if I was given the measurements, I could take away that as the area of the decked area as well. And that would give me my area for my grass that I would need. And as I said before, there may be another follow-up there, and you've got to work out how much would that grass seed cost. Now, if you do get that kind of question, we're talking about 5 or 6 marks. So you're not going to do all those calculations and only get 1 mark and be cheated from it. So if you do get that, that is quite a complicated question. But rather than looking at it and thinking, panicking, well, actually, it's just a series of shapes. So the whole thing is a square or a rectangle and a triangle, and I can work out the area of them. I've got my circle, and my pond is just a circle. So I can take off the area of the circle because I have to do that. And I don't need any grass in my decks area, so I can work out the area of my decks area and take that off as well, and that'll give me the area for the grass area in there. So you may get that kind of complicated or combined shape. There is one here that's going to be, I think you're going to get this one in the practice questions I send after this. So I won't dawdle on this one too long. Looks quite complicated. There's a lot of numbers there, but if you just take it one at a time, you can work out whatever you might need to do there. So quite a lot of detail on there. But as long as you think about them as individual sections, circles, triangles, squares or rectangles, follow the rules that we've gone through in this webinar, hopefully you'll be able to follow that. So before I go any further, I wondered if there's any questions based on shapes and space, particularly circles, triangles and squares or rectangles.